you got on your test? I got a 43. I even studied. At least it's a prime number.
I don't know how, but I got a negative 15.
Gee whiz, we really are gonna fail this class.
Whoa there, children. Why the long faces?
What the F of X? Where'd that voice come from?
Think of me as your calculus conscience, here to help you guys learn calculus and have a rad time too.
Hey, that doesn't sound half bad. Where do we start?
Let's start with your academics. We should be able to calculate the average of your grades as you get more assignments to get an idea of where you're at.
Oh, brother.
As you see here, Stephen's grades seem to follow a geometric pattern. Every grade is 7/8 of the previous grade. So we can calculate the average grade after 20 assignments using this definite integral. It seems to be at 22.306%. Wow, this is going to be harder than I thought. Well, let's see what you need for your 21st grade to pass the class. To find the next grade Stephen needs, we can use the same integral, but this time add g, the variable for the next grade, to the integral before taking the average. Once you solve for g, you get 813.883%.
That's reassuring.
Well, I guess we should get to work then. Alright kids, let's go into that van and we'll go to the park.
Okay. Right, just remember kids, adult supervision is required. Do not try this at home.
The key to being a calculus king is to try to include calculus in your daily activities, for instance, while playing catch.
I guess that makes sense.
So how do we do that?
Patience.
What a load of baloney!
Who can say where the road goes, where the day flows, only time.
Assuming the ball was thrown at a horizontal velocity of 400 meters per second, how far does the ball travel in 1/100th of a second? So we can model vertical acceleration as y double prime of t is negative 9.8 meters per second squared. If you took a physics course, it's probably the first thing you learned, and if you had Stevenson, it's probably the only thing you learned. Then you can find y prime of t, which would be the vertical velocity, by integrating negative 9.8 dt and finding negative 9.8 t plus c1. And c1 will just be in the initial vertical velocity, which we speculated to be about 10 meters per second. And then we're given that the horizontal velocity, x prime of t, is equal to 400 meters per second. Then we can create a velocity vector out of the horizontal and vertical velocities, and using the distance formula for vectors, we can just sub in our values and take the integral from 0 to 0.01, which is the time it takes to hit Stephen, and then take the square root of 400 square plus negative 9.8 t plus 10 square dt, and we get that the ball traveled 4.0012 meters. See, that wasn't so hard, was it?
Oh, my head.
Now I know that I should use calculus and throw it shorter so that I don't hit Stephen in the head.
Now you've got it.
Sometimes calculus appears unexpectedly, but you should be fine as long as you remember your dx's and plus c's.
All right! Holy shell method! Nick, are you okay?
Who cares if he's okay? We should practice calculus instead. Given that Nick's vertical velocity is 4 meters per second at a height of 2 meters, and his horizontal velocity is 2 meters as he leaves the swing, find the impact velocity of his skull as it smashes into the ground 1.4 meters away. The function for vertical position in meters can be modeled by y of t equals negative 9.8 times t squared plus the vertical initial velocity times t plus the initial height. And horizontal position can be modeled by x of t is equal to the horizontal initial velocity times t. So once you substitute in the initial velocities and height, you get y of t equals negative 9.8 t squared plus 4t plus 2, and x of t equals 2t. Since Nick's skull collided with the ground 1.4 meters away, substituting in 1.4 meters for x of t, you can find t to be 0.7 seconds. This is Nick's air time. Now, to find the impact velocity, we just substitute 0.7 seconds for t in the derivative of the y function over the derivative of the x function to get an impact velocity of negative 4.86 meters per second. That must have hurt. Alright, I guess on the bright side he's only severely injured.
I don't feel so good. Maybe next time you jump off a swing, you should do it at a less lethal velocity.
Haha, that's right, Noah.
Hey, maybe we should go into that dangerous looking forest over there.
Sounds like a good idea.
Calc stuff hasn't been so bad. I feel like I can do more gooder on the AP exam now that I've practiced.
Yeah, I feel the same way. Ah! Ah! Alright!
Holy factorial! Noah was bitten by a king cobra!
Hey guys! Alright! I can go louder!
We should call for help!
The only help you need is with calculus. Let's see if we can calculate when the venom entering Noah's body reaches a lethal amount. If the rate at which venom enters Noah's bloodstream can be modeled by the function dy dx equals x over 60 plus y over 100, and it takes 175 milliliters of venom to kill a human, approximate the time in seconds at which Noah dies using Euler's method with time intervals of 30 seconds. If we start at x equals 30 seconds after Noah was bitten and assume that 30 milliliters of venom have entered his body, we can use a
Clearly labeled table
to find how long it takes the venom to end his life. If we substitute 30 seconds and 30 milliliters into the formula for the rate at which venom enters Noah's bloodstream, and multiply that by the 30-second interval between estimations, we get the difference of 24 milliliters between the amount of venom at 30 seconds and the amount of venom at 60 seconds. To find the estimation at 60 seconds, simply add the calculated difference to the previous volume of venom to get 54 milliliters. This process is repeated for the estimation at 90 seconds, the difference again found by subbing the time and volume of venom into the rate of change formula and multiplying by the 30-second interval to get a difference of 46.2 milliliters. Then add that to the previous volume of 54 milliliters to get 100.2 milliliters. For the next estimation, the difference is calculated to be 75.06 milliliters, and since 100.2 milliliters plus 75.06 milliliters equals 175.26 milliliters and is greater than the lethal amount of 175 milliliters, Noah will die after approximately 120 seconds or 2 minutes. Oh man, it looks like we took too long, but that was a good Euler's method example.
But he's dead!
Oh yeah, I guess he is.
That's all I got to say about that.
For instance, while playing catch. For instance, while playing catch. That's your.
What a load of baloney!
Ah! Woo! Holy shell method, Nick, are you okay? You gonna say something, narrator?
No.
Whoa, fuck!
Oh, that was so
Holy
realistic.
shell method, Nick, are you okay? All right.
All right, I guess on the bright side, he's only severely injured.
Oh, that's me.
Yeah. But he's dead.
You gonna say your line, Nick?
Now I know that next time I should use calculus and throw it shorter so that I don't.